Hi all, welcome to ANIL NAIR classes. Now today we are going to discuss a special session on right-angled triangles. Right-angled triangles, total 9 sessions we completed till now on geometries. Now we are at 10th session. We are at 10th session, session number 10. In this session number 10, there are two concepts which I am going to discuss. The first is all the concepts based on right-angled triangle. Right-angled triangle. And the next concept is on virtual positioning. Next concept is on virtual positioning. These are the two concepts which we will discuss in detail. Kindly let me know in the live chat, are you facing any audio issues? Any audio issues are you facing? Any streaming issues? Once you acknowledge saying that no issues, I will start the class. Kindly sit in the class with a notebook and a pen. Very interesting concepts which we will discuss based on right-angled triangle. Based on right-angled triangle which we will discuss. Right, extremely important topic. Right-angled triangle and virtual positioning. Kindly reply in the live chat if everything is clear. Hi all, welcome to ANIL NAIR classes. Now today we are going to discuss a special session on right-angled triangles. Right-angled triangles, total 9
Are you getting any background?
Till now on geometries. Now we are at 10th session. We are at 10th session, session number 10. In this session number 10, there are two concepts which I am going to discuss. The first is all the concepts based on right-angled triangle. Right-angled triangle. And the next
Any background issue?
is on virtual
We'll ask the
positioning.
students only directly.
Next concept is on virtual positioning. These are the two concepts which we will discuss in detail.
1 minute,
Kindly
the
let
voice
me know
is
in the live
repeating.
chat, are you facing any audio issues?
Is there an
Any
issue
audio
right now?
issues are you facing? Any streaming issues? Once you acknowledge saying that no issues, I will start the class. Kindly sit in the class with a notebook and a pen. Very interesting.
Are you facing any
concepts.
issue? Is the voice repeating? Kindly reply in the live chat. I switched off all the external audio devices. Any voice repeating right now? All the external audio device. Are you facing any issue, Praveen? Right. Now, listen carefully, sir. Praveen, right? Just give me 1 minute, we'll start the class. A charger ఒకసారి పైకి లేపు, ఓ బాటిల్ వాటర్ పెట్టు, చాలా ఫిట్ అవుతుంది ఇది. Right, so I think everybody is saying okay. So we'll start the class. Right, now it is 3:05. We'll take the class from 3:05 to 5:05 p.m. covering some very good concepts on right-angled triangle. Now, first we'll write down some important key points. ABC. ABC is a right-angled triangle. If it is a right-angled triangle, one angle will be 90 degrees. Angle B is nothing but 90 degrees. Angle B is 90 degrees. If one is theta, next angle will be 90 minus theta. 90 minus theta. That means in a right angled triangle, three angles in a right angled triangle will be of the form theta 90 90 minus theta, theta 90 90 minus theta, theta 90 90 minus theta. If I take it as x z y, x plus y is equivalent to z, x plus y is equivalent to z. That means if the angles of a triangle are, if the angles of a triangle are in the form angle x, angle y and angle z, sum of two angles equivalent to third angle, sum of two angles equivalent to third angle. If sum of two angles is equivalent to third angle, then the triangle name is right angled triangle. Then the triangle name is right angled triangle. Right? This is the first important key point. Write down in the same way, sir. Right? A right angled triangle is a triangle in which one angle is 90 degrees. So, and the largest side is nothing but the side opposite to 90 degrees. Side opposite to 90 degrees is nothing but the largest side. Side opposite to 90 degrees is nothing but the largest side, which we will call it as an hypotenuse. Hypotenuse is the largest side in a right angled triangle. In a right angled triangle. In a triangle, if sum of two angles is equivalent to third angle, then the triangle name is right angled triangle, and the side opposite to 90 degrees is called the largest side. Largest side is also called the hypotenuse. This is the first introductory slide to right angled triangle. Now, next important slide. Next important slide. Definitely one or two questions will definitely come in your exam from a right angled triangle. Right? Now, if you see, angle B is 90 degrees. Opposite to B is small b. Opposite to A is small a. Opposite to C is small c. That means according to Pythagorean theorem, hypotenuse whole square equivalent to, hypotenuse whole square is equivalent to base side S1 square plus S2 square. S1 and the S2 are the other two sides. One could be a base and another could be a height. So, B square equivalent to C square plus A square. B square equivalent to C square plus A square. Please write down this point. B square equivalent to C square plus A square. That means angle B is 90 degrees. If it is A square equivalent to C square plus B square, angle A is 90 degrees. If it is C square equivalent to A square plus B square, angle C is 90 degrees. If the smallest side is B, angle B will be 90. If the smallest side is A, angle A is 90. If the smallest side is C, angle C is 90 degrees. Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. Right? I hope it is clear. Next important key point. First 5 minutes introduction, then we will get into a concept application. Pythagorean triplets. Pythagorean triplets. Pythagorean triplets. Pythagorean theorem states that if it is ABC and it is 90 degrees, so Pythagorean theorem states that AC whole square equivalent to AB whole square plus BC whole square. AB whole square plus BC whole square. Any Pythagorean triplet, these ABC, these ABC, these m square plus n square, and it is m square minus n square, and it is 2mn. It could be into k also. It will give you all the derived triplets. It will give you all the derived triplets. All the derived triplets. Any Pythagorean triplet, hypotenuse is of the form m square plus n square, height is of the form m square minus n square, and base is of the form 2mn. High frequency Pythagorean triplets. High frequency Pythagorean triplets. How to determine Pythagorean triplets, which we already did it. So 1 is 3, 4, 5. If the lowest side it is an odd number, what we will do? We will square it and divide by 2. 9 by 2 is 4.5. Subtract 0.5, add 0.5. If the lowest side is an odd number, square it and divide by 2. 5 square by 2, which is 12.5. Subtract 0.5, add 0.5. If the lowest side is an odd number, you can get the other two values. 7 square by 2, which is 24.5. 24 and 25. If the lowest side, if it is 9 square by 2, 81 by 2, which I will get 40 and 41. These are all the triplets which I am going to use it right now in today's class. So I am just repeating some important concepts. In case if you have not done a revision, this could also be a revision for the coming class. 3, 4, 5. If the lowest side it is an odd number, square it and divide by 2 and do plus or minus 0.5. You will get all the high frequency Pythagorean triplets. Square it and divide by 2. Suppose if it is an even number, if it is 6, square it and divide by 4. 6 square divided by 4. 36 by 4, 9. Subtract 1 and add 1. So I will get 6, 8, 10. Suppose if it is the next even number 8. 8 square by 4. 64 by 4 is 16. Subtract 1 and add 1. Suppose if it is 10. Square it and divide by 4. 100 by 4 is 25. 25 minus 1 and 25 plus 1. So like that, if it is 12. 12 square divided by 4, which is 36. 12, 36 and 35 and 37. I hope it is clear. 12, 35 and 37. And another important observation. First write down this one. If the side is an odd number, what is the logic? Side square divided by 2. Plus or minus 0.5. This is the lowest side. If it is the lowest side, take the number, square it and divide by 2. Do plus or minus 0.5. If the side is an even number, and it is the lowest side is greater than 4. Side square divided by 4. Do plus or minus 1. I hope it is extremely clear to you, because any 2D figure, if I drop a perpendicular, there is a chance that I will get a right angle triangle. Listen carefully to every concept today. Side is an even number. Side odd number and side even number. Side odd number and side even number. Now if you observe some basic Pythagorean triplets, 3, 4, 5. 5, 12, 13, 7, 24, 25, 9, 80, 40, 41. All the basic Pythagorean triplets, where the lowest side, if it is an odd number, if you check it out, these 3, 4, 5. Hypotenuse plus the other largest side, sum is nothing but a perfect square. If you observe, B plus C is giving you a perfect square, and if you observe A plus C by 2, it is also giving you a perfect square. B plus C, right? 5 plus 4 is 9. 5 plus 3 by 2, it is also a perfect square. All right, HCF of A comma B comma C, it is 1, right? And HCF of A plus B plus C, it is nothing but 1. ABC are co-prime numbers. If the HCF of ABC is 1, ABC numbers are co-primes, and ABC represents the sides of a right-angled triangle. It represents the sides of a right-angled triangle. Then if you see, 5 plus 4 it is 9, which is a perfect square, and A is less than B is less than C. A is less than B is less than C, right? So B plus C, 5, 12, 13. If you observe, 13 plus 12 is 25, which is a perfect square. 13 plus 5 by 2, it is also a perfect square. 9. 25 plus 24, 49 is a perfect square. 25 plus C by 2, 16 is a perfect square. 81, it is a perfect square. 50 by 2, it is a perfect square. 60 plus 61, 121, it is a perfect square. 72 by 2, 36 is a perfect square, right? I hope it is clear to you, right? I hope it is clear to you. This idea, it is clear. Next one, please write down, sir. 1 minute. I hope this idea is clear. If A is less than B less than C, and A, B, C are co-prime to each other. A, B, C are the sides of a right angle triangle. B plus C, it is a perfect square. A plus C by 2 is always a perfect square. Right? Now see here, again I am saying before I get into the concept, in a right angled triangle, in terms of angles, these is nothing but 90. These theta, these 90 minus theta. In terms of angles, sum of two angles is equivalent to third angle. Sum of two angles, it is equivalent to third angle. That is nothing but, now 90 minus theta plus theta equivalent to 90. Right? These two angles is equivalent to the third angle. Third angle is nothing but the angle where 90 degrees is formed. Where 90 degrees is formed. If it is a right angled triangle, ABC, this is small b, this is small a, this is small c, b square equivalent to a square plus c square, b square equivalent to a square plus b square. Right? Rajat, you are asking a question, right? I said that this is 90. This is 90 minus theta plus theta. Please read this statement. Sum of two angles is equivalent to third angle. Third angle is the angle where the angle 90 degrees is formed. Third angle is the angle where it is 90 degrees is formed. If it is angle B, angle A plus angle C is equivalent to, right, angle B. It is nothing but angle A plus angle C is equivalent to angle B. Sum of two other angles are sum of non-90 degree angles. Sum of non-90 degree angle is equivalent to 90 degrees angle. Sum of non-90 degrees angle is equivalent to 90 degrees angle. I hope it is clear. Or in other words, suppose see here, this is ABC, this is 90 degrees, these AC is nothing but the largest side, AC is nothing but the largest side. If it is largest side, 90 degrees is the largest angle. 90 degrees is the largest angle. So, sum of smallest two angles, is nothing but equivalent to largest angle. If sum of two smallest angles is equivalent to largest angle, then the triangle is called the right angled triangle. Then the triangle is called the right angled triangle. Then the triangle is called the right angled triangle. This is theta and it is 90 minus theta. Sum of smallest two angles is equivalent to largest angle. Then the triangle is called as right angled triangle. Next one. Now write down this point. No similarity. Instead of using similar triangles, how you can find out by using sine rule or a cosine rule. No similarity in a right angled triangle. No similarity in a right angled triangle. No similarity in a right angled triangle. First concept is if two right angled triangles are similar, then they follow the same basic Pythagorean triplet. Extremely important concept, sir. If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. When I say basic Pythagorean triplets, HCF of triplets should be 1. HCF of Pythagorean triplets should be 1. 3, 4, 5. It is a basic Pythagorean triplet. 6, 8, 10. 6, 8, 10 is a derived version of 3, 4, 5, which is 3, 4, 5 into 2. This is a derived triplet. If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. Please write down this point. Next 45 minutes to 1 hour, we are discussing the same concept. Then the right angle, if two right angled triangles are similar, then they follow the same basic Pythagorean triplet. Converse is also true. If two right angled triangles are following the same basic Pythagorean triplet, then they are similar to each other. If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. Example. Suppose if there is a right angled triangle 3, 4, 5, this is 90, this is theta, and it is 90 minus theta, 4 and 5. Suppose if I enhance this right angled triangle, this is 90, this is theta, and it is 90 minus theta. Theta opposite, it is 3. This also should be of the form 3k. 90 minus theta opposite, it should also be of the form 4k. 90 opposite, it is also of the form 5k. If the triangle is stretched, then the k is nothing but the multiplication factor. K is nothing but the multiplication factor greater than 1. If the figure area is enlarged, then the multiplication factor will be greater than 1. Suppose if the figure is condensed, if this is 90, this is theta, and it is 90 minus theta, 90 minus theta opposite, this will be 4a, and this will be 3a, and this will be 5a. So here it is nothing but the a is the condensing factor. These triangles ABC. Next it is DEF. ABC is similar to DEF because of AAA property. Angle property. If three angles of a triangle are equal, then obviously they are similar triangles. Theta 90, 90 minus theta. Theta 90, 90 minus theta. Theta 90, 90 minus theta. If it is enhanced, then k will be multiplication factor greater than 1. If it is condensed, a will be less than 1. If a equivalent to 1, that means these two figures are exact mirror images of each other. If two right angled triangles are similar, then they follow the same basic Pythagorean triplet. If two right angled triangles are similar, then they follow the same basic Pythagorean triplet. Once we solve as many problems as possible, then it will be extremely clear to you. K is a multiplication factor greater than 1. A is a condensing factor less than 1. I hope this point is clear. Next one. Another important key point. Suppose there is a right angled triangle These nothing but A, B and C. Drop a perpendicular. If I drop a perpendicular, these 90 degrees and these also 90 degrees. These also 90 degrees. So area of triangle ABC. Area of triangle ABC is nothing but half into base into height. Half into AB into BC. It is nothing but half into base. Base if I take it as AC, height will be AD. This is nothing but small a. These nothing but small b. And these nothing but small c. These nothing but small c. So it is nothing but half into a into c equivalent to half into BD is nothing but height. It is nothing but b. Half of cancel. So H is nothing but a into c by b. A into C by B. So to determine the height of a right angled triangle, height is nothing but product of the sides containing 90 degrees, product of the sides containing 90 degrees divided by the hypotenuse. Product of the sides containing 90 degrees divided by hypotenuse. I hope the idea is clear. If a right angled triangle is given, height is nothing but product of the sides divided by hypotenuse. Product of the sides containing 90 degrees divided by hypotenuse. Now, first problem, please write down. Side heading, no similarity. No similarity in right angled triangles. No similarity in right angled triangles. No similarity in right angled triangles. Now see here, first point, first question. ABC is a right angled triangle. ABC. These 90 degrees. These 90 degrees. From B, I dropped a perpendicular. So BD is perpendicular to AC. BD is perpendicular to AC. This value is 6. This value is 8. So what are all the values that I need to determine? First traditional method, then optimal method. Method number 1. Method number 1. What are the things that I need to determine? BD I need to determine. AD I need to determine. DC I need to determine. BD, AD and DC I need to determine. ABC is a right angled triangle with angle B 90 degrees. AB is 6 and BC is 8. BD is a perpendicular drawn onto AC. BD is a perpendicular drawn onto AC. Now see here. First it is 6, 8. If two right angled triangles are similar, then they follow the same basic Pythagorean triplet. 6, 8. These nothing but 2 3s are 6. Next it is nothing but 2 4s are 8. Next it is nothing but 2 5s are 10. 6, 8, 10. That means hypotenuse value is nothing but 10. Hypotenuse we got it as 10. Right? Next one. BD. BD is nothing but product of the sides containing 90 degrees by hypotenuse. These is nothing but 48 by 10. So answer for this BD value is 8. BD value we got it as 8. BD we got. Now we will do AD and DC slowly. AD and DC slowly. I hope BD is clear. Height is nothing but product of the sides containing 90 degrees divided by the hypotenuse. These BC. These nothing but 8. These nothing but 6. These nothing but 10. Listen carefully, sir. Step number 2. Once you understand step number 2, this is a perpendicular. This is D. This is 90 degrees. 90 degrees. If this is theta, this will be 90 minus theta. Angle B is 90, so it is theta. Angle in a straight line is 180, so this is 90. This will be 90 minus theta.
This will be 90 minus theta. Now if you observe, there are three triangles which are formed. One is triangle ABC. Triangle ABC. What is the behavior? A is 90 minus theta, B is 90 degrees, and C is nothing but theta. 90 minus theta, 90 theta. 90 it is similar to 90 minus theta is nothing but B, and 90 is nothing but D, and it is C. Which triangle it is? Triangle BDC. This is also similar to 90 minus theta, which is A, 90 which is nothing but D, right, and B it is nothing but theta. Triangle ADB. If you observe triangle BDC, B is nothing but 90 minus theta, D is nothing but 90, C is nothing but theta. ADB. ADB is also of the form 90 minus theta, 90 and theta. Outer triangle is similar to inside top triangle. Outer triangle is similar to inside bottom triangle. Inside top and bottom are also similar to each other. There are three triangles which are similar to each other. Triangle ABC is similar to triangle BDC. Triangle ABC is similar to triangle BDC. Triangle ABC is of the form 6, 8, 10. Listen carefully, sir. 6, 8, 10. This is 90 degrees. This is theta, and it is 90 minus theta. Now, if you observe, if two right-angled triangles are similar, then they follow the same basic Pythagorean triplet. 6, 8, 10 is derived from 2 into 3, 4, 5. That means the first triangle is taking the Pythagorean triplet 3, 4, 5. 3, 4, 5. What does that mean? 3, 4, 5. Theta opposite is 3 into something. 90 minus theta is 4 into something. 90 opposite is 5 into something. 6, 8, 10 is of the form 2 into 3, 4, 5. Now let me take a triangle BDC. If I take a triangle BDC, if one side if we know, we got the answer. If I take these BDC, this value is known. 8 is nothing but opposite to 90 degrees. Opposite to 90 degrees is nothing but 5 into something. This also it will be 5 into something. So A value is 1.6. A is 1.6. Theta opposite in an outer triangle. Theta opposite in an outer triangle it is 3 into something. In an inside bottom triangle, it should also be 3 into something. It should also be 3 into something. That means BD is nothing but 3 into 1.6, which is 4.8. Outer triangle, 90 minus theta is nothing but 4 into something. If I take a triangle ABC, 90 minus theta is 4 into something. Inside bottom, 90 minus theta also it should be 4 into something. It should also be 4 into something. So 4 into, this is nothing but 1.6, which is 6.4. If it is 6.4 out of 10, this is nothing but 3.6. All the values we got. One is AD value 3.6, DC value 6.4. DC value 6.4. Again I will solve it for the second time so that it will be clear to you. First take a side where all the three triangles are known. 6, 8 and 10. Check whether it is a basic Pythagorean triplet. It is not basic Pythagorean triplet. It is 2 into 3, 4, 5. That means the basic Pythagorean triplet which I need to use is 3, 4, 5. Take that triangle as a reference. Go to any triangle where one side is known. If one side is known, suppose let me take with an inside top. If I take with an inside top it is nothing but 90 opposite is 6. 90 opposite it is 6. In actual triangle, what is 90 opposite? It is nothing but 10. So 5 into B is 10. B value is nothing but 1.2. What are A and B values? Shrinking factors or the condensing factors? In an outer triangle, 90 minus theta is 4 into something. 4 into something. Here also 90 minus theta will be 4 into something, 4.8. Theta is nothing but 3 into something. This is 3 into something. 3 into 1.2 is 3.6. Without using any similarity, just with a line. If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. Then they follow the same basic Pythagorean triplets. Then they follow the same basic Pythagorean triplets. I will do one or two questions more so that you will feel extremely comfortable in this logic. I hope it is clear. So answer is, what is the answer we got? Answer we got it as, this value we got it as 4.8, this value 3.6, this value 6.4. It is 90 degrees. These is nothing but 6. These is nothing but 8. And the total value is nothing but 10. This is the answer we got for the previous question without using any similarity. How we got this answer? I hope it is clear. Question number 2. Question number 2. 3 questions I will solve. Then you will feel extremely comfortable. Then you will feel extremely comfortable. Then these nothing but ABC. ABC is nothing but a right angled triangle. Angle B is 90 degrees. AB is nothing but 10. BC is nothing but 24. BC is nothing but 24. Drop a perpendicular from B onto AC. Let me call this point as D. We need to find out AC. We need to find out BD. We need to find out AD. And we need to find out DC. We need to find out DC. Right? Now, method number 1. Method number 1. Listen carefully, sir. If this is 90, first identify the angles. These theta, 90 theta. These nothing but 90 minus theta. Total is 90. These 90 minus theta. These theta. These nothing but 90. These is nothing but 90 minus theta. So outer triangle is similar to inside top and inside bottom. So 3 triangles are similar. Step number 1. What are the values that are given? 1 is given as 10. Height. Base is given as 24. These nothing but 2 5s are. These nothing but 2 12s are. Next it will be 5 12 13 is a basic Pythagorean triplet. 10 24 27. So it is derived from which basic Pythagorean triplet? 2 into 5 12 13. 2 into 5 12 13. Our entire focus is on 5 12 13. If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. That means this value is nothing but 10. This value is nothing but 24. This value is nothing but 26. Step number 2. Step number 2. Assume that you forgot that height, product of the sides by hypotenuse. See here, sir. It's very easy if you understand the procedure. First take a triangle where all the 3 sides are known. 10, 24 and 26 are known. Take any triangle, either inside top or inside bottom. Check for one side where the value is known. Inside bottom, one value is known, that is 24. 24 is opposite to 90 degrees. 24 is opposite to 90 degrees. Actually in the triangle, opposite to 90 is 26, which is 13 into A. So inside bottom also, it should follow the same basic Pythagorean triplets. So A is nothing but 24 by 13. Opposite to theta, in an outer triangle where all the 3 values are known, 10 is 5 into something. So BD value is nothing but 5 into 24 by 13. 5 into 24 by 13. That can be determined also by using this formula. Product of the sides by the hypotenuse. This is nothing but 5 into 24 by 13.
5 into 24 by 13. So these are nothing but 5 into 24 by 13. Opposite to 90 minus theta, it is 12 into something. Opposite to 90 minus theta, it is 12 into something. 12 into 24 by 13. 12 into 24 by 13. Again, see here, sir. Again, see here. Opposite to 90 is 13 into something. Opposite to 90 is 13 into something. So K value is 10 by 13. K value is 10 by 13. So it is nothing but opposite to theta is 5 into something. Opposite to theta is 5 into something. So these is nothing but 5 into 10 by 13. 5 into 10 by 13. I hope it is clear. 5 into 10 by 13. So you will get any values that is possible because of this, or you don't need to do it. These nothing but 27 minus 10 into 24 by 13. 10 into 24 by 13. 10 into 24 by 13. Kindly reply in the live chat if this idea is clear to you. Idea is clear to you. I hope the idea it is clear. So what actually I am doing it is, there is one triangle which is 10, this is 24 and it is 26. This is 2 into 5. This is 2 into 12. Here it is 2 into 13. This is nothing but 2 into 13. 2 into 5, 2 into 12 and 2 into 13. There is another triangle. There is another triangle where, I hope it is clear, right? So the diagram is like this. The diagram is like this. A, B, C and it is D. D is nothing but 90. Here it is nothing but 24. Here it is theta and here it is 90 minus theta. 26 is becoming 24. 10 will become how much? 24 will become how much? That is what exactly I did it. These is nothing but 90. These is nothing but 90 minus theta. 90 theta, 90 minus theta. I hope it is clear. 90 opposite is 13 into something. It is 13 into 2. Now the value is shrinked. 13 into A is 24. A is 24 by 13. Obviously the value will be shrinked because this is the total triangle. It is the inside bottom. Theta is 5 into 2. This is nothing but 5 into 24 by 13. 5 into 24 by 13. Opposite to 90 minus theta. 12 into 24 by 13. 12 into 24 by 13. These 13 into 24 by 13. One is 13 into 24 by 13. 12 into 24 by 13. 5 into 24 by 13. These is nothing but 5 into 2 and here it is 12 into 2 and here it is 13 into 2. 2 value has been shrinked to 24 by 13. I hope the idea is extremely clear to you. I hope the idea is clear to you, right? I hope the idea it is clear to you. Or if you shift the figure also, answer will change. Not necessarily, Mahesh. You can shift 24 and 10. I will do one more question. I hope this idea is clear. Everybody kindly reply in the live chat if this idea is clear to you. Is this idea clear? Then I will tell you a single step answer where you don't need to do any of this. But how you got that one? That is something which you should know it. Problem number 3. Question number 3. Question number 3. Question number 3. These is nothing but 7. These is nothing but 24. These is nothing but 24. These 90 degrees. These is a perpendicular. These 90 degrees. This is A. These I call it as D. These B and it is C. So what all we require? We require what is BD and what is AD and what is DC. AD and DC.
I hope the idea will be clear after this third example. So these is nothing but 7 comma 24, another triplet lowest side is 7, so 7 square by 2, 49 by 2, 24.5, minus 0.5 and plus 0.5. So here it is nothing but theta, these 7 and 24, these nothing but 25, these nothing but 25, 90 opposite is 25, 90 opposite is 7. So 25 into A is 7. A is the condensing factor, which is 7 by 25. Opposite to theta is 24. 24 into 1. Here also it is 24 into 27 by 24. 24 into 7 by 25. I hope the idea it is clear. Opposite to 90 minus theta. Opposite to 90 minus theta. In an outer triangle, 90 minus theta is 7. So these is nothing but 7 into opposite to right, 7 into 7 by 25. These is nothing but 25 minus 49 by 25. I hope the idea it is clear to each and everybody. Kindly reply in the live chat if the idea is clear to you. Opposite to 90 is 25. Opposite to 90 is 7. 25 into A is 7. That means what is this triangle actually? What is the these B? This is D. These 90 degrees. These theta. These 90 minus theta. So this will be of the form, this is 25 into 7 by 25, opposite to 90 minus theta is, so these is nothing but 7 into 7 by 25, and it is nothing but 24 into 7 by 25. It is still forming the Pythagorean triplet 7, 24, 25. This is the condensing factor. This is the condensing factor. Can you all reply in the live chat if this concept is extremely clear to you? Is this idea clear to you? Is this idea clear to you? Right? How to find out these values? Question number 4. Question number 4. Question number 3. I hope the idea it is clear to you. Question number 4. Now this is a cat question. ABCD. ABCD is a rectangle. ABCD is a rectangle. There is another rectangle which is like this, which we will call it as PQ. BPDQ. BPDQ is a rectangle. BPDQ is a rectangle. ABCD is a rectangle and BPDQ is also a rectangle. What are the values that are given? The values which are given are AD is 12 and DC is 16. AD is 12 and DC is 16. He is asking the figure area of BPDQ. He is asking the figure what is the area of BPDQ. Very, very good question, sir. So ABCD is a rectangle. Every angle is 90 degrees. If this is 90, this is theta, this is nothing but 90 minus theta. BPDQ is also an rectangle. This is theta, this is nothing but 90. This is nothing but 90 minus theta. This is nothing but 90 minus theta. This is nothing but 90 minus theta. This is nothing but 90. And here it is nothing but Q. Here it is nothing but Q. Here it is nothing but 90. So this is nothing but, right from there, all these nothing but theta and it is nothing but 90 minus theta. So many triangles are similar. Now what we require? AD is 12. AD is 12. If AD is 12, what is the value of DC? DC is nothing but 16. If DC is 16, 12, 16, these is nothing but 4 3s are 12, next is 4 4s are, next will be
4 5s are 20, 12, 16, 20. That means if these 12 opposite sides are equal, 12, 16 and it is 20, 12, 16 and it is 20. Single step you can solve. If I take a triangle BCD, what will be the form of BCD? These nothing but 20, these nothing but 12, these nothing but 16, which is 90 degrees. 12, 16, 20 is the derived triplet of 4 into 3, 4, 5. It is derived from 4 into 3, 4, 5. 90 opposite is 5 into something. 90 opposite is 5 into something. So 5 into x is nothing but 16. X is nothing but 3.2. This we got it right. So one length we got 20, breadth if we got the answer. 90 theta, 90 minus theta. 90 minus theta, it is 3 into something. 90 minus theta, this is 3 into 3.2, 9.6. Area is nothing but, this value is 20. So this value will also be 20. This is 9.6. This is also 9.6. Answer is 9.6 into 20. Answer is 192. Answer is 192. What I did, I took these two triangles are similar. So I took these two triangles. Which two triangles I took? One is BCD, where all the three values are known to me, and another is DCQ. Another is DCQ. So I just compared these two triangles and I got the answer. So first I checked the triangle BCD, got the derived triplet, base triplet is 3, 4, 5. Then I went and identified which value has got right opposite to one side. See, basically these two triangles are similar. One triangle, all the values should be given. In one triangle, one side should be given, other two sides can be extracted. Again I am explaining. If two right angled triangles are similar, in this right angled triangle, all the three sides are given, and in this one side is given. Other two sides you can determine it by using this concept. What is the concept? If two right angled triangles are similar, then they follow the same basic Pythagorean triplets. Everybody, Mahesh only replied saying that he is clear. Other students understood, not understood. The only way for me to understand whether you have understood the concept or not is to go through your acknowledgement in the live chat. Question number 4. I hope it is clear. Question number 5. Now see here. There is a triangle ABC. This value is, angle B is 90 degrees. AB is nothing but 9. BC is nothing but 12. There are points of trisection. These is nothing but, point of trisection means it divides the line into 3 equal parts. AD equivalent to DE equivalent to EC. Then these drawn. This entire portion, there is a quadrilateral that is formed inside. This is a quadrilateral. What is he asking? He is asking the area of quadrilateral. If I call it as B, BDEF. Area of quadrilateral BEF. See here, sir. Area of quadrilateral BDEF. Now see here. Listen carefully. AB is 9, BC is 12. AD equivalent to DE equivalent to EC. This is 9. This is 12. These 3 3s are 9. These 3 4s are 12. These 3 5s are 15. 3 5s are 15. So it is nothing but total value is nothing but 15. If it is 15, these 5, these 5, and it is 5. This clear. These 90 degrees. That means this value is theta. This value is 90 minus theta. This value is 90 minus theta. From AC, I have selected 2 points. From here, I have dropped a perpendicular onto. These are all perpendiculars and divides the line into 3 equal parts. It is given in the question that these are all perpendiculars. So, if these are all perpendiculars, these is nothing but this is 90 and it is 90 minus theta. 90, 90 minus theta, and it is theta. And it is theta. So it is nothing but, if I take total triangle ABC minus of triangle AFD, triangle AFD plus triangle EFC, I will get the area of the quadrilateral. Total triangle, so it is 9, 12, 15. Total triangle area is half into 9 into 12 into 15. This is over. Now let me concentrate on AFD. Let me concentrate on AFD. One value I need. If there is one value, I can extract other two values. This is nothing but theta. So 90, 90 minus theta, theta. Theta opposite is nothing but this is of the value 9 and this is of the value 12. Opposite to theta is 9. 9 is 3 into something. Opposite to theta is 3 into something. 3 into A is 5. A is nothing but 5 by 3. A is nothing but 5 by 3. Opposite to 90 it is 15, which is 5 into something. So this value is 5 into 5 by 3. 5 into 5 by 3. This value is 3 into 5 by 3, and this value is 4 into 5 by 3. 4 into 5 by 3. So what is the area of triangle AFD? Half into 4 into 5 by 3 into 3 into 5 by 3 into 3 into 5 by 3. I hope this idea is clear. Total area, top we got. Similarly, bottom. Bottom, if you observe closely, this is nothing but which value it is? 90 minus theta. 90 minus theta is 12 in the outer triangle. So this is nothing but 4 into B is nothing but 5. 5 B is nothing but 5 by 4. B is nothing but 5 by 4. B is nothing but 5 by 4, which is nothing but 4 into 5 by 4. 4 into 5 by 4. Opposite to 90, it is 5. So this is 5 into 5 by 4, and it is 3 into 5 by 4. 3 into 5 by 4. So what is the area of triangle EFC? Area of triangle EFC is half into 3 into 5 by 4 into 4 into 5 by 4. 4 into 5 by 4. Total triangle minus these two triangles, I will get the area of the quadrilateral BDEF. 5 problems based on a single concept. If two right-angled triangles are similar, then they follow the same basic Pythagorean triplets. If two right-angled triangles are similar, then they follow the same basic Pythagorean triplets. I hope it is clear. This is a traditional method. How to get the answer very fast? How to get the answer very fast? What we did is a traditional method, understanding which all triplets are there and checking whether there is a condensing factor or an enhancing factor. I hope the idea it is clear. Right, we can do one more question, then I will tell you method number 2. Question number 6. Please write down question number 6. There is a right-angled triangle. This is A, this is B, and it is C. This is nothing but 6. This is nothing but 8. This is nothing but 10.
This is nothing but 10. This is 90 degrees. So I took this, if I take it as a square, if I take it r, what I'll do is, I'll do it little later, this value. This is nothing but directly xy by x plus y. So this is this. If you observe these points D, E, F, G. D, E, F, G is a square. D, E, F, G is a square. D, E, F, G is a square. ABC is a right angled triangle. ABC is a right angled triangle where angle B is 90 degrees. And DEFG, it is a square. DEFG, it is nothing but a square. We have to find out area of DEFG. We have to find out area of DEFG, which is nothing but a square. Which is nothing but a square. So what I did it is, right, so from here I selected a point on G, I dropped a perpendicular. Again here it is a perpendicular. This is a perpendicular. All are 90 degrees. DEFG. DEFG, it is given that it is a square. Now how to do it? Now see here, sir. Listen carefully. If it is 6, 8 and 10, if this is 90 theta, 90 minus theta, this is square, so it is 90. This is nothing but 90. This is nothing but theta. 90 theta. This is 90 minus theta. This is nothing but 90. This is nothing but theta. And it is nothing but 90 minus theta. All right, outer left, outer down, outer right side, all are similar to each other. If all are similar to each other, first it is 6, 8, 10. 6, 8, 10 is derived from 2 into 3, 4, 5. So my triplets, both the similar triangles will be of the form 3, 4 and 5. 3, 4 and 5. Now see here. It's very easy once you understand, sir. So opposite to theta, it is 3 into something. That means EF value will be 3A. Opposite to 90 minus theta, which is nothing but 4A. That means EC value is nothing but 4A. Opposite to 90, it is 5A. FC value is nothing but 5A. This is 5A. This is 3A. And it is 4A. And it is 4A. I hope it is clear. Now if you see here, DEFG is a square. If it is 3A, this will also be 3A. This will also be 3A. This will also be 3A. Now over answer. Answer is quite visible to us. Opposite to 90. Opposite to 90 is 5K. So 5K equivalent to 3A. So K is nothing but 3A by 5. Opposite to 90, right? So this is nothing but opposite to theta is 6, which is 3. So this is nothing but 3 into 3A by 5. And this is nothing but 4 into 3A by 5. This is nothing but 5 into 3A by 5. Two right angled triangles are similar, then they follow the same basic Pythagorean triplets. Now over, BC is nothing but 8. So 4 into 3A by 5 plus 5A, it is nothing but 8. 12 plus 10, 22A by 5, it is nothing but 8. A is nothing but 40 by 22, which is 22 by 11. Area of this square is nothing but 3A whole square. So 9 into A square. Substitute the value, you will get the answer. I hope the idea it is clear. Right? 6, 8, 10. 6, 8, 10 is nothing but derived from 3, 4 and 5. So all are perpendiculars, 90, 90, 90, 90, 90. So outside, if I take EFC, opposite to 90, 90 opposite in an outer triangle is 10, which is 5 into something. So it is 5A. Opposite to theta is 6, 3A. 3a, 4a and 5a. 3a, 4a and 5a. So this side we got 3a. If this is 3a, this also will be 3a. Are you with me? This also will be 3a. 3a, 3a. Opposite to 90 is 5k. 5 into k is 3a by 5. K is 3a by 5. Opposite to theta is 3 into something. Opposite to 90 minus theta is 4 into something. 4 into 3a by 5 plus 5a. It is nothing but 8. A value we got it. Area of the square is side whole square. Side is nothing but 3a. 3a whole square. 9a whole square. This is nothing but an original exam model question. Original exam model question. Question number 6. All the 6 questions, I hope it is clear to you. Now, see here. Now, method number 2. Listen carefully to every important key point. Method number 2. Now, what we did is nothing but we did basic Pythagorean triplets. Now, method number 2. Listen carefully, sir. This is A, this is B, and it is C. BD is a perpendicular. This is 90 degrees. So, the first it is nothing but half into AB into BC is nothing but half into BD into AC. Half of half cancel. BD is nothing but product of the sides AB into BC divided by AC. This is clear. This is something which we determined. Height is nothing but product of the sides where the 90 degrees is formed, where right angle is formed, divided by hypotenuse. This is clear. Product of the sides where the right angle is formed, divided by hypotenuse. Now listen carefully, sir. I want each and everybody to pay utmost attention. This is nothing but theta. This is nothing but 90 minus theta. This is nothing but theta. This is nothing but 90. This is nothing but 90 minus theta. This is nothing but 90 minus theta. Now see here. Suppose in a triangle BDC, in a triangle BDC means the triangle is like this, D, C and B. This is 90 and angle C is theta. And if you see in triangle BDC, ADB, if I take angle ADB, this is nothing, sorry, not angle ADB. B is 90 minus theta, A is 90 minus theta, D is 90 degrees. Yes, ADB. Okay, right only. A is 90 minus theta. A is 90 minus theta. Here B is nothing but theta. D is nothing but B is nothing but theta and D is 90 degrees. Now listen carefully, sir. Suppose if I take tan theta. Tan theta is nothing but opposite by adjacent, BD by DC. If I take tan of 90 minus theta, tan 90 minus theta is opposite by adjacent, BD by AD. If I multiply both, tan 90 minus theta is cot theta. So BD square is nothing but AD into DC. Very, very important conclusion. Please make a note of it. BD whole square is nothing but AD into DC. BD whole square is nothing but AD into DC. So sometimes what I did triangle BDC is similar to triangle ADB. Triangle BDC is similar to triangle ADB. What is the conclusion I got? BD whole square equivalent to AD into DC. BD whole square equivalent to AD into DC. This is an original exam question. He gave this value. BD
These 90 degrees. This is 16. These 9. And it is 90 degrees. This is C. Find the value of BD. Find the value of BD. BD whole square equivalent to. This is A. BD whole square is nothing but AD into DC. So BD value is nothing but 12 units because it is nothing but 16 into 9. BD square is 144. BD value is 12 units. BD value is 12 units. I hope key point number 2 it is clear. Only AD and DC are given. If these two sides are given, AB and BC is given, it is nothing but product of these sides divided by the hypotenuse. Key point number 2. I hope it is clear. Next, key point number 3. Very, very important key point number 3, sir. Extremely important key point number 3. Key point number 3. Listen carefully. ABC, ABC. This is A, this is B, and it is C. It is a perpendicular. This is 90 degrees. This is also given in the question that it is 90 degrees. This is theta and it is 90 minus theta. This is nothing but theta. This is nothing but 90 minus theta and it is 90. And it is 90. Now see here, listen carefully. So this is nothing but cos theta. Cos theta is nothing but adjacent side by. Please listen carefully, sir. Once you understand this conclusion, it is a single step. Cos theta is nothing but adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. Sin 90 minus theta. Sin 90 minus theta is nothing but cos theta. Sin theta is nothing but opposite side by hypotenuse. Sin theta is nothing but opposite side by hypotenuse. Let us take cos theta in the triangle BDC. In the triangle BDC. If I take in the triangle BDC, cos theta is nothing but adjacent is DC by opposite. Hypotenuse is side opposite to 90 degrees, which is nothing but BC. DC by BC. I hope it is clear. Similarly, in the ABC triangle, sin theta, sin of 90 minus theta, it is opposite by hypotenuse. Opposite by hypotenuse. What is sin theta? Opposite, which is nothing but BC by what is hypotenuse? AC. Sin 90 minus theta is equivalent to cos theta. So if I equate both, DC by BC is equivalent to BC by AC, then it is nothing but DC is nothing but BC square divided by AC. DC is nothing but BC square divided by AC. That means if this is A and it is C and this entire value is B, this value is simply, it is nothing but A square by B. A square by B. Similarly, you do ADB with ABC. This is nothing but C square by B. Very easy. If I want this AD, it is nothing but C square by hypotenuse. If I want this DC, it is nothing but A square by hypotenuse. Extremely important key point, sir. Very, very important key point. Please make a note of it. Otherwise, you will waste your time. AD is nothing but C square by B. DC is nothing but A square by B. That means now from now onwards, instead of doing Pythagorean triplets, you can directly tell this answer. This is ABC. this value is 6 and this value it is 8. These are nothing but a perpendicular BD. All the values we require. 5 seconds you can tell the answer. BD is nothing but 6 into 8 by 10, which is nothing but 4.8. This entire value will become 10. AD is nothing but, you don't need to do anything. It is nothing but C square, 6 square by 10, 36 by 10, 3.6. DC is nothing but 8 square by 10, which is nothing but 6.4. 6.4. I hope it is clear. Directly it is 3.6 and directly it is 6.4. Idea clear? Right? Directly you don't need to do anything. You don't need to do anything. Right? So, very important 4 conclusions that we will write down in our single slide right now. So, if ABC is a right angled triangle, the first important key points. First important key point is, if this is D, first point is BD is nothing but AB into BC divided by AC. This is the first key point. Second key point is BD square is nothing but AD into DC. Second key point, AD is nothing but AB whole square divided by AB whole square divided by AC. Then last key point, CD is nothing but BC whole square divided by AC. Very important conclusions. Very important conclusions. Please make a note of it and put a star mark to it. Extremely important conclusions. Extremely important conclusions. Height is nothing but product of the sides divided by hypotenuse. BD whole square is AD into DC, and AD is nothing but AB square divided by AC, and CD is nothing but BC square divided by AC. BC square divided by AC. I hope it is clear. Right? Now see here. Another important point. Fourth point, I hope it is clear. Fifth point, this is ABC. This is ABC and BD is perpendicular to AC. BD is perpendicular to AC. If BD is perpendicular to AC, what is AD we got? AB square divided by AC. What is DC we got? This DC is nothing but BC square divided by AC we got. Are you all with me? So these is nothing but area of a triangle ADB. ADB, it is nothing but half into AD into height. These is nothing but, right? So what I will do is height of the figure ADB. These perpendicular. Am I right? These perpendicular. Right? Base into height. Assume that AB is the height. And area of triangle BDC. If I take base as DC, these also nothing but height will remains the same, because the right BDC half into base into height. These nothing but HH cancel. So triangle ADB area by triangle DBC area, ADB area and the triangle DCB area are in the ratio AD is to DC, are also in the ratio AB square by
BC square. Please make a note. Triangle ADB area and the triangle DBC area. ADB base is DB, DBC also base is DB. Base is same, so areas will be there in the proportion of the other side because the heights of the two figures are also same. ADB by DBC area, it is nothing but AB whole square by BC whole square. AB whole square by BC whole square. I hope the idea it is clear. Now if you see here, suppose if there is a question, not suppose, this is an exact original exam question. This is nothing but 6. This is nothing but 8. This is a perpendicular. This is a perpendicular. This is A and it is B and it is C. A, B, C. So he is asking, find the area of triangle ADB. Find the area of triangle ADB and also find the area of triangle BDC. Area of triangle ADB we require and area of triangle BDC also we require. Now see here, what is that we discussed? This ratio of their AD is to DC. AD is to DC, in which ratio it will be there? 6 square is to 8 square, which is 36 is to 64. This 36 is to 64. I hope it is clear. So these is nothing but 36 parts and it is nothing but 64 parts. Total 100 parts, it is nothing but the total area half into 6 into 8. So this is nothing but A is nothing but 24 by 100, which is nothing but 4 6 are 4 25s are, right? So this is nothing but 6 by 24. So what is the area of ABD? Easy question it is. Area of ABD, it is nothing but 36 into 6 by 25. What is the area of DBC? DBC is nothing but 64 into 6 by 25. 64 into 6 by 25. I hope the idea is clear to you. If it is 6 and 8, this will be there in the ratio 36 and 64. So these area of ADB is in the ratio AD square, area of DBC is in the ratio 64A. Total area is nothing but 36A plus 64A, 36A plus 64A, which is 100A, which is nothing but total area half into base into height. So A is 6 by 25, area of ADB is 36 into 6 by 25, DBC is 64 into 6 by 25, 64 into 6 by 25. I hope the idea it is clear. Next two concepts, please write down. Next two concepts. Next two concepts. These are all some of the exam model diagrams. Exam model diagrams. Exam model diagrams. So the first diagram, these like this. I think the time is close to 4:20. Another 15-20 minutes. This concept will be extremely clear to you. ABC. ABC is a right angled triangle. So angle B is 90 degrees. Angle B is 90 degrees. First figure. First figure, the diagram is drawn like this. Let me draw the diagram. A square is inscribed in a right angled triangle. A square is inscribed in a right angled triangle. A square is inscribed in a, this point is here. A square is inscribed. This star is not there. The figure is like this, 90 degrees. Let me call this square as DEFG. DEFG. So let the side of the DEFG.
let side of DEFG, it is nothing but A. This is nothing but A. Now listen, please listen carefully, sir. DEFG, let the side of DEFG is A. Now what we have to do is, some value will be given. Which value we will take? We will take this value as X, this value as X, and this value is A. We have to do the area of this square DEFG. Area of square DEFG. Side of DEFG is A. Area of the square we need to do. Area of this square we need to do it. Now if you see here, this is 90. This is nothing but theta. This is nothing but 90 minus theta. And this is nothing but 90. This is nothing but 90. So what we'll do is, this is nothing but 90. Let me call this value. Let me call this value. I think in addition to this, there is one more diagram also. Now see here, this is X. Let me, this P let us call. This is nothing but A. This is nothing but B. This is nothing but C. This is nothing but C. 90 theta, 90 minus theta. Now, this is a right angled triangle. Now see here. Listen carefully, sir. Let the side of the square is P. Let it be P. What we will do is cos theta. This is nothing but 90. This is nothing but 90. This is nothing but 90. This is 90. This is 90. How to convert the side of the square? How to convert the side of the square into the sides of a right angled triangle? Into the sides of a right angled triangle. That is my entire ideology. Now if you see here, cos theta is nothing but, cos theta is adjacent by hypotenuse. So x by hypotenuse we call it as CG. CG I will call it as x by, let me call it as CG. Cos theta is nothing but CG. Next one, if what is this triangle I took? I took the triangle GFC. I took the triangle GFC. Similarly, if I take the triangle ABC, sine of 90 minus theta. Sine theta is nothing but, what is this sine 90 minus theta? Opposite by hypotenuse. Hypotenuse is nothing but BC by AC. It is nothing but BC by AC. Now 1 minute, sir. Now I understood, right? 1 minute. The diagram is like this. Now this is ABC is a, just a small correction, sir. ABC is a right angled triangle. This is also right. This is also right. This, and it is this. This is nothing but D. This is nothing but E. This is nothing but F. This is nothing but G. DEFG, it is nothing but a square. So what is given here is AE is given as A. FC it is given as B. He is asking, find the area of this square. Find the area of this square. DEFG. This is the question. AE value is given, FC value is given. Find the area of this square DEFG in terms of A and B. In terms of A and B. Now if you see here, this is 90. This is nothing but theta. This is nothing but 90 minus theta. This is nothing but 90. This is also 90. This is nothing but theta. This is also 90. This is 90. And it is 90 minus theta. This is nothing but, let this value is given as B. This value it is given as A. If this is X, this also will be X, because in DEFG square all the sides are equal. All the sides are equal. all the sides are equal. Now we will get the answer aram se. Now if I take in triangle GFC, in triangle GFC, cos theta, it is B by X. So cos tan theta, if I take tan theta, tan theta is nothing but opposite by hypotenuse, which is X by B. Similarly, G is 90 minus theta, so it is A. F is 90, AED. In triangle AED, tan 90 minus theta, tan theta is nothing but opposite by tan 90 minus theta, opposite by hypotenuse. This is nothing but X by A. Tan 90 minus theta into tan theta, X by B into X by A equivalent to 1. X is nothing but root of A into B. Please write down this conclusion. X is nothing but root of A into B. This value is A and this value it is B. How to find out the side of the square? Side of the square can be determined by the value x equivalent to root of A into B. Only this value is given and this value is given. X is nothing but square root of A into B. Original exam question. X is nothing but root of A into B, which is an original exam question. Original exam question. I hope it is clear. There is a right angled triangle and DEFG is a square which is inscribed in a right angled triangle. AE is given and FC is given and we have to find out the area of the square. So triangle GFC and it is triangle AED. From there you will get the conclusion. I hope it is clear. This is one model. Let us take an example. Once you understand that x is root of A into B, then your job becomes easier. Suppose if it is like this, this is like this, this is like this. If it is 16 and it is 9, what is the area of the figure? Area of the figure is nothing but side whole square. It is given that it is a square, so this is nothing but side is nothing but root of 9 into 16, root of 144, which is nothing but 12. Side is nothing but 12. Area of the figure is 12 square, which is 144. Very, very important idea, sir. ABC, if this is 90 degrees, then how to do it? I hope the idea it is clear. Area of the figure is side whole square, which is 144. There is another exam variety that comes in your exam. What is that variety? We will also see that one. So I hope this variety is clear. Next variety, ABC. The square is like this. ABC. This is a right angled triangle. ABC. This is a right angled triangle. ABC. This is a right angled triangle. And DEFB. DEFB, it is a square. DEFB, it is a square. DEFB, it is a square. So what are the sides that are given? Let me call the side as x. So this will be a minus x. This is nothing but a minus x. What are the other values that are given? This is nothing but x. This is nothing but x. So what is the area of the square? Can you all give it a try, sir? Let me see whether the question is right or wrong. This is nothing but, okay. So what we'll do is, we'll make a small change here. This is nothing but, when the sides are given, AB is given as x and BC is given as y, where AB and BC are the sides of a right angled triangle. So if I take square side of a square as A side of a square, let it be A. If I take it as A, if this is A, this will be x minus A. If this is A, this will be y minus A. I hope it is clear. So what we have to do is area of this square is nothing but side whole square, which is nothing but a square. X comma y are given. If x comma y are given, how to find out the area of the square? Because it is a square, this is 90 degrees, this is theta, and it is 90 minus theta. This is nothing but 90. This is nothing but 90. It is a square. This is nothing but 90. And it is nothing but 90. This is nothing but 90. This is a straight line. So it is theta. And it is 90 minus theta. And it is 90 minus theta. This is nothing but A. This is nothing but A. This is x minus A. This is nothing but A, y minus A. From there easily you can solve this. Now see here. Suppose if I take tan theta is nothing but opposite by adjacent, opposite side by adjacent. So if I take opposite by adjacent, which is nothing but A by x minus A, A by x minus A. Suppose if I take tan theta here, this is nothing but y minus A by A. This is nothing but A square equivalent to xy minus A of x plus y plus A square. A square cancel. So A is nothing but, very important conclusion, sir, x into y by x plus y. Area of the square is given by A in x into y by x plus y. So square, area of the square will become xy by x plus y whole square. Xy by x plus y whole square. Very important, sir. Very important idea. If DEFB is a square that is inscribed with one point as the point of the right angle triangle and the two sides of a right angled triangle are given, then how to find out the area of the square that is inscribed in a right angle triangle? Answer is xy by x plus y whole square. Xy by x plus y whole square. So these is nothing but, if the square is inscribed like this, if the square is inscribed like this, this is A, this is B, and it is C, and this value is 6, and this value it is 8. What is the area of this square? DEFB. DEFB area is nothing but xy by x plus y whole square. 6 into 8 by 6 plus 8 whole square. 48 by 14 whole square, which is nothing but 24 by 7 whole square, which is 7 3s are 21, 3.4 whole square, closer to 11.56. DEFB area is nothing but 6 into 8 by 6 plus 8 whole square, 48 by 14, which is 24 by 7 whole square. Answer is 3.4 whole square. I hope all these concepts are extremely clear to you.